This video is on 11.4. So the previous video was talking about simplifying rational expressions. This time we're going to multiply them and also simplify. So this first screen here is the problems I'm going to talk through. And you'll see on the next slide that I kind of write over top of them. So I wanted to provide you with a fresh list of all the problems without any writing on them first. So here we go. So this is where I cross some things off. So it can kind of get a little messy. I'll explain a few of these. I'm not going to talk through every single problem, but just a couple of them. So on number 11, you had 10n squared times 2 at the numerator and 4 times n at the denominator. So when we multiply normal fractions, we can go straight across numerators and multiply the denominators together. Or you can look on diagonals for simplifying first. So if you look on the diagonal, that kind of the 2 and the 4. So think if you had 2 over 4 as a fraction, that reduces to a half. So you can take away the 2 and make it a 1, and take away the 4 and make it a 2. So I'm essentially dividing each of those terms by 2. Then the 10 and the numerator, I can divide out with the 2 that I just rewrote over top of the 4. So that, again, divides by 2. So 10 over 2 is the same as 5 over 1. So that's how you see those markings there. And then for the variables, you have n squared up top and 1n at the bottom. So if you think one of those cancels out, top and bottom, so you're left with just 1n. So that answer is 5n. Similarly, number 13, I saw the 2 and the 18 on the diagonal, so I divided those both by 2. So the 2 became a 1 and the 18 became a 9. And then you have to look at variables. So the y's on the diagonal divide out, so they're gone. The x's, you have 5 x's in the numerator and 1 x in the denominator, so you're going to have 4 x's left. And then the z's, you have 4 in the numerator, 3 in the denominator, so there's only 1 z left there. So let me talk through a few from the bottom set. This is when they are all factored for you. You just have to look for common factors on diagonals or crossing off a numerator with a denominator that are the same. So that first example there, you can look on the diagonal, and the 9 and the 3 are both divisible by 3. So 9 divided by 3 just turns into a 3 over 1. On the binomials, on those diagonals, you can see the t minus 2 was same as the t minus 2 underneath. So those can cancel each other out and divide out. So the only thing you have left at the top is a 3 with a t plus 2 in parentheses, and the only thing left at the bottom is a 1. Number 16, you can see that the a plus 4s on the numerator and the denominator can divide away. And then one of the a's from the numerator can cross off one of the 2 a's that are down below in the denominator on that diagonal. So you're just left with a 6, an a minus 5 in parentheses at the top, and 1a down below. On number 17, you can see that the k minus 1s on that diagonal cross away, likewise with the k plus 2s. And the last k plus 1 in the numerator can, even though that's not on a diagonal, it can still divide out the k plus 1 in the denominator. So the only thing left here was the k plus 6. And 18, the r plus 3s go away. One of the, let me look what that was. One of the r's at the top numerator, divide out one of the r's in the denominator, so you're just left with 2 r minus 8 in parentheses over the r plus 8 in the denominator. So those are nice when everything's factored for you. You can just like cross away things that are similar. And then finally, ones like these, it has 3 steps for you to follow. Step 1, factor the numerator and denominator. So factor everything that you can. Look for GCFs, look for difference of squares, look for trinomials. So this first one, the a plus 4, you can't do anything with. The a squared, you can't factor that. The second fraction, the numerator of a, can't do anything. The only piece that you can factor here is the trinomial a squared plus 2a minus 8. So again, make an x model off to the side, or think two numbers that multiply to negative 8 that add to a positive 2. So that factors into a minus 2 and a plus 4. So then on that diagonal, you have the a plus 4s that go away. And then on the other diagonal, one of the a's at the top cancels out one of the two a's at the bottom. So the only thing left at the numerator was a 1, and then an a with an a minus 2 at the denominator. So you're going to cross off common factors after you have everything factored to simplify it. The one below it, y squared minus 1 is a difference of squares, so make sure you can recognize that. And that factors into y plus 1 and y minus 1. Likewise, y squared minus 49 is also a difference of squares, which factors to y plus 7 and y minus 7. And then the second fraction, you can't simplify that at all. So when you look on diagonals, the y plus 1s go away, the y minus 7s go away, and you're just left with a y minus 1 over a y plus 7. And then here are 3 extra examples. I'll talk through specifically 1c. The numerator on the first fraction, y squared minus 3y minus 4. That is a trinomial that you can factor. So that is numbers that multiply to negative 4 that add to a negative 3. So that factors into y minus 4 and y plus 1 over a y plus 5. The second fraction is y plus 5, which you can't factor. The denominator of this one's a little bit different, that it has just a GCF of a y that you can bring out. So that factors into a y, and then parentheses y minus 4. So looking on diagonals here, the y plus 5s go away, the y minus 4s go away, and you have y plus 1 over a y. And you can kind of read through the other examples on this. But the key thing is, like before, like in the second examples here, you can't just cross off the y squareds. And then in the second one, you can't just cross off the y's. You have to factor everything first. That's super important with these questions.